Hello everyone. So today we will discuss about the topic of the basic concept of microservices. So I will give some of the major points of microservices as you can see in this small session. So first we will know what is microservices. Okay. So let's start our discussion by setting a foundation of what microservices are. So microservices basically are a way of you can say breaking large software projects into loosely coupled modules, right? Which communicate with each other through a simple called APIs, means application programming interfaces. So microservices have become increasingly popular over the years, as everyone knows. So they are an example of the modular architecture style, right? Based on the philosophy of breaking large software projects into smaller, independent, loosely coupled parts, which has gained prominence among developers today for its dynamic and agile qualities in this API management and execution of highly defined and discrete tasks. So this is the basic concept of microservices. So in simply, if we started, so we can say that microservices are really nothing more than another architectural solution, if you can consider, for designing a complex or mostly today's world web-based applications. And microservices have gained prominence as a evolution from the service-oriented architecture today's world, an approach that was designed to overcome the disadvantages of our traditional monolithic architecture. I will come into that monolithic architecture. So basically, now we will go for the history of microservice. So what? So if you can say in a simple example, so suppose I need to build a classic web application using Java, right? So the first thing that I will do, so design a presentation layer. That is the user interface. So we can simply like create this type of and web application. So after the user interface, it will be followed by an application layer, right, which handles all the business logic here. You can see, and this is followed by an integration layer to enable loose coupling between various components of the application layer. And finally, I will design a database layer that will accessible to the underlying persistence layer to run the entire application. To run the entire application, that I have to create a WAR file or a ER file to create the package so that we can deploy it in the application layer, the base server like JBoss, Tomcat, or WebLogic. I think in your college days you can know what is Apache Tomcat server, right? Because and because I have a package and everything is a ER WAR file, so my application becomes monolithic in nature, which means that even though we have separated the distinguishable components, all are packaged together. So this is the, as you can see, illustration of an monolithic architecture. So in the monolithic architecture, it is basically a traditional, you can say, unified model for the design of a software program. It's in monolithic in its context means composed all in one piece, and simply deployed on a set of identical servers, like I said, Tomcat or something, with a load balancer. So its main advantage is that it's very simple to deploy, develop, test, deploy, and scale. Right. So this is the basic concept of monolithic architecture. So why we need to switch from monolithic to the microservice, right? So there are some flaws. So what are the flaws of monolithic architecture? As you know, the application grows, so does the associate code base, because if you are increasing the applications logics, so it will inherently increase the code base, right? So which can overload our development environment each time it loads an application, reducing the developers productivity, right? Because this application has been packaged in a var or ER file. So changing, if we want to change its technology stack, means we can change its logic, and we can develop in any other language of the application becomes, that time it becomes very difficult task, right? With in uh, its kinds of architecture, refactoring the code base becomes very difficult, and it's hard to predict how it will impact our application functionality, right? And if a single application or function or component fails, like we can see here, there are some four types of services. So if single application fails, if a part, and then the entire application will be goes down, right? Because it's totally controlled by one server. Imagine a web application with separate functions and including payment, login, history. If a particular function starts consuming more processing power, the entire application's performance also will be compromised, right? So another flaw is the scaling of monolithic applications, such as one in the example can be accomplished by deploying the same package of the WAR or that ER file in additional servers. We can say it by scaling, like horizontal scaling. Each copy of the application in the additional server will utilize the same amount of underlying resources, which is inherent and inefficient in its design. It is not a good design, right? And also monolithic architecture impacts both the development and application deployment in the stage. As you can see, application increasing in size, it's even more important that developers also to able to break their application down into smaller components, because if, everything in the monolithic approach is tightly coupled together, right? Developers cannot work independently to develop or deploy their own modules, and they must remain totally dependent on each other. So increasing that is overall deployment. So this is the drawbacks of monolithic architecture. So with these thoughts in mind, so we can explore the value of microservices and how they can be used to provide the flexibility that's lacking in the monolithic architecture. So the theory behind the microservice service. So we will discuss that. So one of the major driving force behind any kind of architecture solution is scalability, right? Many of our previous peers in the software architecture and development world have, you can say, innovated or gravitated towards a concept called scalability, art of scalability. It's concept defining a model that was called scale cube, which describes 3 dimensions, as you can see from this diagram, 3 dimensions. So as you can see, the x represents the x axis, represents the horizontal application scaling, which is we have seen is possible with the monolithic architecture. We can see that part can possibly be monolithic. And the z axis, this z axis represent the scaling the application by splitting in similar things. The z axis idea you can imagine can be better understood by using the shredding concept, right? Where the data is partitioned and the application redirects, you can say, request to corresponding threads, different threads based on the user input. You can say as it can be done commonly with the database also. And the y-axis, this y-axis represent the functional decomposition. So in this approach, various functions can be seen as independent service. It is not dependent like in the monolithic type, right? Instead of deploying the entire application into once all components are available. So the developers can deploy the respective service independently. They don't have to depend on each other. And this not only improves the developer time management, but also you can say offer great flexibility to change and then redeploy their modules without worrying about the rest of the other components of the applications. It's right. So you can see from the previous diagram. So if you can consider this as a microservice, so this is the how it is different from the earlier diagram, right? Which we shown here. That all are in a single module, but in the microservice you can see it's an independent module. It is controlled by one particular things like the storefront, but the building web application, this one, inventory web applications, shipping web application, these are independent modules. So independently some developers can deploy develop, deploy, and can, there is no dependency. If one of the modules gets fails, it will not affect this inventory. If billing fails, then it will not affect the inventory, right? So this is the concept of microservice. So we will now discuss the advantage, the basic advantages now for microservice. So the advantage of microservice can be seen strong enough through the enough to convince the some of the big enterprise players like today's world, Amazon, Netflix, and to adopt the methodology that we already discussed. So compared to monolithic design, so we will compare with monolithic structure, right? What microservice offer, what are the advantages? So first and foremost, we can see it is the improved fault isolation. What is fault isolation? See, large applications can remain mostly unaffected by the failure of a single module, that I already explained, that if one application fails, it will not affect the other application, right? And the next is the eliminator of vendor by or technology lock-in. What is this? Means microservice provide the flexibility to try out a new technology stack or individual services as needed. So there won't be as many dependency concerns, or rolling back changes become much more easier with the less code play. So right, because that what I mean to say, that suppose this application is written in one tech stack, one technology, one programming language. This can be written in another technology. There is no issue because they're independently, totally independent, right? The third point is the ease of doing understanding. So what is ease of understanding? Ease of understanding is with added this kind of simplicity, developers can better understand the functionality of a service, right? Next, smaller and faster deployments. Smaller and faster deployments, we can say that with smaller code base and scope, with quicker development, which also you can see, you can start to explore the benefits of continuous developments in Jenkins, this kind of DevOps tools, right? Then the scalability, as you see, scalability, since your service is separated, you can more easily scale the most needed ones and the appropriate times, as opposed to the whole application when it comes from monolithic. So when done correctly, this can impact huge cost savings, right? So cost savings is a very, very important factor nowadays. But with the advantage, there are some disadvantage also. So what are the disadvantages? We have to consider those things also. First is communication between services complex, right? Communication, since everything is now an independent service, you have to very carefully handle requests traveling between your modules. In one such a scenario, the developers may force to write extra code to avoid disruption, right? Over time, complications will arise when remote calls, you can say, experience some of latency or delay. That is one, you can say, one of the disadvantages. Next, what we can say, more services equals more resource, right? So multiple database transaction management, painful thing, because we have, for every single application we have separate database, right? So global testing is difficult, right? Because testing a microservice based on application can be cumbersome. So when it is a monolithic approach, we just need to launch a work on an application server and ensure the connectivity with the underlying database. But with microservices, each dependent service needs to be individually tested before the final testing happen, right? Debugging problems also one of the problem. It's a harder thing. Like each service has its own set of logs go through. So the logs, there are more logs, right? Deployment challenge. So the product that may need coordination among multiple services, which may not be as straightforward as deploying a word in a container, right? So there are different types of applications, small applications. So they have to be deployed together. And the last, what I understand, that the large and small product companies. So microservices are great for large companies because, but it can be slower to implement and too complicated for small companies who need to create and iterate quickly and don't want to get bogged down in a complex construction, because large, for company there are huge number of applications, but small, their resources are limited, they need fast accessibility, right? So that is the thing. So in this module, we can just go through just the deployment of the microservices in a small at a glance. So that now we understand microservices, so how they are deployed, right? So the best way to deploy microservice based application is within the containers, which are means complete virtual operating system. There are no means logical, right? So the virtual operating system environments that provides processes with isolation and you can say dedicated access to the underlying hardware resources. So one of the biggest names in this container solution right now, you can see familiar Docker. You might heard this term Docker. So we will come later, which can be done in the later part. So what is virtual machine from infrastructure provides like AWS is a very common, Amazon Web Service, like can also work for well for microservice deployments. But relatively lightweight microservice packages may not leverage that the whole virtual machine, potentially that reduce the cost effectiveness, right? So, and the code deployments can also be completed using an open service gateway, we can say the OSGI bundle. So in this use case, the all application service will have to run under means one JVM Java virtual machine. But that also, but this method also comes with, you can say, the management and means isolation trade-off, right? So we will more discuss about this thing when we will go in deep. So finally, we can say means how to move forward with the microservice, right? So as the application development trends continue to evolve, the debate between using microservices or leveraging traditional monolithic architecture will only become more pronounced, right? So in the end, developers must do their, I can say, with due diligence and understand means what will work for their specific use case. So for smaller companies, starting with a monolithic application can be very simple, faster and cheaper. But if the product hasn't gotten much too mature, it can still be migrated to microservices at an appropriate time, not maybe the initial time. So the huge companies with millions of users, millions and real time, every time accessing the sites are obvious example of the best use case for the microservice, as they need to ensure that uptime, scalability, and the added mobility can provide. So this is, I can say, the basic overview of microservices. So that is all that we can say for this introductory module. So we will learn the other parts in the later upcoming module. Thanks for watching.